Hello and welcome, Nord Anglia, and thank you for joining us for our MIT abstract on what to wear in space with Harvard MIT Health Sciences and Technology graduate student Rachel Bellisle. I'm your host, Fatima Hussein, and I'm a PhD student here at MIT studying ancient Earth. Now, before we begin, I'd like to cue you all in to what an abstract actually is. So an abstract is actually just a snapshot or a summary of a greater work of research or writing. And with this series, MIT Abstracts, we're bringing these snapshots of inspiring MIT experts straight to you wherever you are around the world. So now I'd like to kick us off and invite Rachel to join us this morning. Good morning, Rachel.
Good morning. How are you doing?
I am doing just dandy. How are you?
Good.
Awesome. Well, Rachel, I am so incredibly excited for your talk, so I'm going to let you take it away.
Okay, so I will get started. Thank you for the introduction, Fatima. So I'm going to be talking about what to wear in space. And before that, I'll give you a quick introduction to who I am. So I originally got my bachelor's degree in biomedical engineering from the University of Rhode Island in 2018. But now I'm a PhD student at MIT. So I'm actually a medical engineer, but I'm focusing in human spaceflight and bioastronautics. So I'm not an astronaut, asterisk, right? I'm not an astronaut, but I'm a PhD student learning about keeping astronauts safe and healthy in space. So I have a fun picture here with me and a bunch of spacesuits that we were showing at a conference recently. So I thought that was a fun photo to share with you. But other things about me, I actually have a lot of hobbies in the arts, or I used to be really into both kind of performing like music and theater and visual arts. Now it's more so a hobby, but it's pretty interesting. When I was in high school, maybe where some of you might be or earlier, I really didn't know whether I would be going into the arts or engineering. And so I chose the engineering route, but it's really come almost full circle because in the project I work on now, I work with a lot of designers and also fashion people. When you're designing clothing and garments for people, you inevitably have these really awesome collaborations in that way. So it's really cool to kind of reconnect with some of my personal interests, even now as a trained engineer. But moving forward, I wanted to talk to you guys about the history of spaceflight a bit. When I started my PhD degree, I actually had never worked on space professionally before. I'd only worked in medical engineering kind of for Earth applications. So I had a really quick learning process. I'm going to take you guys through some of that and get you all caught up to speed on kind of human spaceflight, kind of the general history and where we are now. And so the question I like to ask is, when was the last time humans were on the moon? I know you guys can't answer, but I'll give you the answer here. It was in 1972. So it was over 50 years ago, which is pretty crazy. Most people don't think it was quite that long ago. But we had 6 different crewed landings to the moon, totaling on 12 humans on the surface of the moon. And one of the videos I like to show here is these, what we call moon bloopers. So these are astronauts actually on the moon, and you can see they have these big spacesuits on, protecting them from the environment and the vacuum of space around them, but they're quite difficult to walk in and move in. And so they are really stumbling around and struggling on the moon. They're really big, bulky garments. Nowadays, we're no longer sending astronauts to the moon, but we're going to the International Space Station. So this is orbiting Earth. And we have astronauts actually in microgravity. So instead of having this partial gravity on the moon, where you weigh about 17% of what you weigh on the Earth, this is actually essentially weightlessness. And so these suits don't have to be mobile, don't have to allow astronauts to walk and run on the moon, but they're still quite difficult to use and pretty bulky. Astronauts complain a lot about the gloves because it's really difficult to move their fingers and perform all of the tasks that they need to do during their spacewalks. One of the reasons it's so complicated is that this is just a really complicated garment. It has to keep the astronauts safe from a lot of different risk factors in their environment. It's obviously keeping them enclosed and providing an atmosphere around their body. It's gas pressurized. And there are up to 14 different layers in the suit as well. So think of your kind of heaviest winter gear, your winter jacket and your snow pants, and then add a couple more layers on top of that. And think about how well you move around and how well you could do really complex tasks. It's maybe close to what the astronauts have to deal with, but it's very difficult to move around. And so there are some thoughts. This is an idea coming out of my lab. It's a mechanical counterpressure suit. This one is called the biosuit. So I've gotten to work a little bit on parts of this project in my lab. It's a next generation spacesuit concept. So what if instead of providing a gas pressurization around the body, this kind of shrunken down spacecraft around the body, instead of that, let's apply pressure directly onto the skin, actually just stretching the material over the skin and providing a lot of pressure and using that to protect the body from the environment. And so this is the concept for that, definitely reducing the bulk of the garment, maybe also increasing mobility and making it a lot, causing less moon bloopers when we go back to the moon and Mars. So it's a really cool concept here. But what I really want to talk to you guys about is actually the microgravity environment and what happens to the human body in microgravity. This is one of my big research areas here at MIT. In spaceflight, both like microgravity environment and radiation and all of these other factors, the human body changes a lot and adapts to this new environment somewhat. Sometimes it's an inappropriate adaptation. So all of these different systems in the body that I've listed on the screen here might be affected by spaceflight. Two of the big ones that you might have heard before, but I'm going to go over them, is bone loss. So when you are standing up on Earth, you're always getting loads from gravity, right? So you're standing up and gravity is pushing down on you and all of your bones respond to that. And that's how your bones kind of stay strong. And when we remove that and we go into microgravity, the bones slowly start deteriorating. And there's a loss in bone mineral density and strength. So that can lead to a risk of injury or fracture and all of these really bad outcomes that we don't want our astronauts to have to deal with. There's also muscle atrophy. When you're weightless and you don't have any resistance to your movements, your muscles are no longer working and they atrophy and lose strength. This is especially relevant in some of these muscles that help you to stand up or walk around on Earth, right? Because they're no longer used in space. And so depending on how long you're in this microgravity environment, these muscles can really deteriorate. Right now on the International Space Station, we combat both of these effects with exercise. So astronauts actually exercise about 2 hours every single day using some of these pieces of equipment here. There is a cycle ergometer, so kind of cycling. There's a resistive exercise device that you can see in the middle here. And then there's a treadmill, and they actually bungee the cord them down to the treadmill so that they can stay running even in that microgravity environment. And so these do a pretty good job of keeping our astronauts safe when they return to Earth, but bone and muscle loss still occur anyways. All of the numbers that I showed you in those previous slides, if you're looking, all happen even with the exercise they already do. So they do a pretty good job, but we still have some bone and muscle loss and other effects after spaceflight. And the even more interesting thing is that we probably won't be able to bring those big exercise devices to the moon or Mars, maybe. So this is a picture of the International Space Station on a football field. And you can see this tiny little blue box down at the corner. Let's see if I can put my laser pointer on here. This tiny little blue box is the size and comparison of what the Orion capsule might look like, which is kind of the proposed spacecraft that might be going to the moon and Mars. So not going to be a lot of room for bulky exercise equipment. So we think that in the future, exercise and kind of countermeasures, the ways that we're trying to prevent all of these physiological changes, these changes to the human body, these countermeasures are going to look a lot different. It's going to be maybe modified exercise devices, but also kind of different things that we're using to supplement exercise. And one of the ones I'm most interested in, and we're looking at in my lab, is wearable countermeasures. What we wear in space might matter a lot more in the future. And that is what brings me to the gravity loading countermeasure skin suit. I usually just call it the skin suit because it's a pretty long name here. There's a bunch of photos of it here. You can actually see the black suits, and all of these photos are the skin suit, and also this blue suit here. And so this is a suit, not that they wear outside of the vehicle on their spacewalks, they actually wear the suit inside of the vehicle. It's actually been flown on the ISS a couple times. For tests, they don't use it all the time, but they've been testing it on the ISS, which is really exciting, and we're continuing to develop it for spaceflight. There's been a lot of different versions of the suit over the years. You can see this kind of nice figure here of all of these different suits. The idea of this suit is that we're trying to reload the body. I mentioned to you guys that on Earth, you're constantly receiving forces from Earth's gravity, and that's what's keeping your bone and your muscles and other parts of your body strong and healthy. And so the idea is that we're reapplying this load, the suit. We create a garment that's a lot smaller than you'd normally wear. And then when you put it on, it kind of loads onto your body. So if you stretch the fabric to put it over your body, and then it shrinks down and provides a force going downwards. And you can actually see in this picture here, so we have this force going vertically, and then it's anchored at the shoulders, and then there's stirrups or like straps going underneath the bottom of the feet. And we also have kind of circumferential pressure around your body to keep everything nice and anchored. And so that's kind of how the suit works. And one of the most interesting things that I get to work on is how do we test the suit? Because we can't just send it into space every time we want to test it and see how it works, because it's a lot of money to send things into space. And so we need to find analogs on Earth. So an analog is something we're using to represent different parts of the space environment. So one of the first analogs I'll talk to you about is this here, which is the Moonwalker. This is what we call our partial gravity simulator that we have in the lab at MIT. And so it's this big structure. You can actually see it kind of in the background here, this big structure. And we actually can put a participant in a harness. This is actually me here in the Moonwalker. So I'm in a harness, and it's actually pulling up and offloading a certain portion of my body weight. And so it can allow me to run in a lunar or Martian gravity simulation, which is pretty fun. And so that's one of the ways we can test the suit. We can also use something called a parabolic flight. And so this is an actual plane in the sky. And the plane takes a parabolic flight pattern. So you can see this little graph here. And so when we're climbing up, there's actually a period of hypergravity. So it's when you weigh more than you would weigh on Earth. And it's a lot of pressure, right? And then we get to the top, we're kind of pushing over the top of the curve, and we experience a period of microgravity. So actual weightlessness in the plane. And so we get about 20 seconds of that. And what's really cool is I actually got to experience this last May. It was really fantastic, and hopefully doing it again this May too. And we got to test the skin suit in this environment on this aircraft in free fall in the sky, which was pretty awesome. We also got to experience some lunar and Martian gravity in this as well, because depending on how they kind of tune this curve, they can simulate lunar or Martian or any level of kind of partial gravity in addition to microgravity. And then the last analog I wanted to introduce you guys to was bed rest studies. So both of the analogs I told you about previously were kind of, we can have somebody run on the treadmill for like maybe an hour or something in the lab, or we can have someone go up in the plane and experience 20 seconds of microgravity. But how do we know what happens over long periods of time? Because that's really important if the body is deteriorating and we want to see how the suit or another countermeasure interacts with that and mitigates that. So we can do bed rest studies. You might have heard of NASA paying lots of money to people to stay in bed for 2 months. This is what we're talking about here. So it's a pretty interesting analog. I actually haven't done anything like this before, but it's a pretty valuable one for some of the things we're trying to test. And with that, I wanted to wrap up kind of this portion of the talk and just end with a bigger question of why should we send humans? I just talked about all of the reasons why it's hard to send humans to space, and we have to do a lot of work to keep them safe and healthy. So like, why are we sending humans in the first place? Can't we just send robots, right? And we have sent robots. This is the Perseverance robot, the Perseverance rover, which is currently on Mars. It was launched most recently. And the thing that most people don't realize is that there's been a couple different rovers, but all of those rovers cumulatively have only traveled about 59 miles on the surface of Mars. 59 miles, it's not very long. I'm from the state of Rhode Island. I used to be able to say that the rovers hadn't crossed like the kind of southern to northern tip of Rhode Island. It's a little bit more than that now. It's about 10 miles greater than the distance of Rhode Island, but it's the smallest state in the US, and the rover has just barely traveled the length of Rhode Island, which is pretty crazy. And so we think that when we send humans to Mars, we'll far exceed that 59 miles that we talked about. And that's from 50 years of space flight, right? We'll far exceed that in our first human mission to Mars, which is pretty exciting. And with that, we get a lot of benefits. We can really dig into the science and the exploration of being on another planet and learn things about our solar system and maybe about our Earth too. And there's a lot of technology development that assists these missions. So a lot of technology development that even trickles down to Earth, and we see the benefits in our day-to-day life. And we get the inspiration of all of us here on Earth I get to talk to you guys about how excited I am about spaceflight, and hopefully you are too. And so we get a little inspiration here on Earth, which is a lot of fun. And with that, I'm just about finished, and we can go through any questions that you all might have.
Fantastic. Thank you so much, Rachel. That was so exciting. I even have a lot of questions of my own, but a lot of Northern Anglia students seem to have beat me to the really good ones. So let's dig in. I think one of our Northern Anglia students is wondering if you could walk us through why that bone loss happens in space again, and then how the suits actually change and counteract that.
Yeah, awesome. So with bone loss, so the key thing to remember is that on Earth, you're always loaded by gravity, right? Your bones are used to having a lot of force on them, because if you think of the way your body works, right? The weight of your head weighs something, right? And so the weight of your head is loaded onto your shoulders, and the weight of your head and your torso is loaded onto your hips. So you have a lot of load on your body. And so that's the environment that bones are used to. And there's something called Wolff's Law. So this is getting into the science a little bit. It's called Wolff's Law. And it's that bone in a healthy person or an animal, it could be an animal too, will adapt to the loads that it's placed under. So if it's placed under high loads, it'll be really strong to resist those loads. If it is placed under lower loads, it no longer has to resist that force, and it can deteriorate a little bit. So bone is really, really sensitive to the loads you're applying to it. And so in microgravity, we no longer have any resistance or loading on our body. We're essentially in weightlessness. And so these little sensors in the bones that detect load are not stimulated. And so the bone isn't prompted to grow or maintain its density. For countermeasures, what we really want to do is replace those loads, right? And the biggest way we do that is actually with exercise. Bone responds really well to dynamic exercise. So if we're running on a treadmill or something like that, where we're getting like cyclical, really dynamic movements. There could be some effects from the countermeasure garments as well, so the skin suit, but I think the exercise actually is probably more important for bone than the skin suit will be.
So just like exercise is extremely important for us here on Earth, even though we have that load and the effect of this amount of gravity, it seems like it's really important in space. And now I want to take us to our most upvoted question from a North Anglia student. And they're wondering, how do astronauts breathe when they're wearing the skin suit, and how much does it weigh in the first place?
Okay, so there's a couple of things here. So I guess, so the skin suit, like I said, is a suit that we wear inside of the vehicle. So when they're wearing the skin suit, they can breathe whatever air there is in the spacecraft, right? When they're inside of the space station. So there's really nothing that no breathing apparatuses are really involved, because they're kind of in their spacecraft, in their livable environment. But what I think you're talking about is the biosuit. So it's this kind of advanced concept suit that really like shrink wraps the body so that they're safe in the vacuum. I think that's the one they're talking about, right? And so that's a great question. So most of the body is shrink wrapped, right? And kind of squished and protected with skin compression, protected from that vacuum environment. But we do need breathing air, right? You are really correct in thinking, where is the breathing air coming from? So we have actually a helmet that provides gas pressurized like environment around the head. So there is kind of this really tough kind of design challenge of how do you transition at the neck from having a gas pressurized helmet to a really tight skin compressive garment on the rest of the body.
And so I think one of the things that this student might be wondering is, when they're wearing something this compressive, I mean, how easy is it like to take a big deep breath if you're being squeezed so hard?
Yeah, that's a great question too. So for the biosuit, something we've looked into in some of the earlier prototypes is having a breathing bladder underneath, kind of on your torso. So there would be a big bladder underneath the suit. And as you breathe in, maybe that would lose air. And as you breathe out, it would fill with air to kind of fill that space. So it keeps a consistent volume to allow you to more easily breathe. So that's the thought for the biosuit, but it is a really difficult design challenge. For the skin suit, it's a little bit more reasonable. We're not getting quite so high pressures. Think about maybe your like workout leggings or something for the girls at least, or some sort of tight compressive garment that you already wear. So that's kind of what the skin suit will feel like. So it's not too difficult to breathe in the skin suit.
And so you liken the skin suit to the workout clothes we might wear here on Earth. Does it weigh, as much as those as well? Is it pretty light? Is it pretty heavy? What are we talking
Yeah,
about?
the skin suit, I can crumple it up in a ball and put it in my backpack. It's great. So that's one of the reasons it's really potentially valuable for the moon and Mars, because if we have we're worried about space, right? We can't bring these big, huge exercise machines. So what if we have something that we can, crumple up in a ball and throw in a little backpack or a corner or something? That's something we can really easily bring with us on this mission.
And I think another Nord Anglia student's wondering, what if they wanted a skin suit here on Earth, for example? How much does it cost to actually make one of these
How
things?
much does it
Yeah.
cost? So it costs currently about $1,000 a show, which isn't bad when you think about how much a kind of an EVA spacesuit costs. So the spacesuits that they use for spacewalks are absurd amounts of money. But the skin suit is really just a garment. It's essentially like what we said, kind of a workout garment. And so we actually send this to a costume designer, and she's worked with us for about 10 years now, and like is an awesome collaborator with us, and develops these suits right in the Boston area. So it's a lot of fun. And on Earth, I will say, if you want to wear one on Earth, they're a little uncomfortable on Earth, right? Because you're getting the loading of gravity and you're getting the loading of the suit, right? So it's a little uncomfortable in Earth's gravity. But if you bring it up to microgravity, I think it's a little better. That's what I think.
Got it. So acquire the $1,000 spacesuit and then go up into microgravity environment. Okay, that's on the Nord Anglia student checklist now. We have a really wonderful question from Avni, who's in grade 3. And Avni's wondering, who inspired you to be a PhD student? What inspired you to do this?
That's a great question. I actually never thought I would be going to get my PhD. If you asked me, even when I was in college, even like my first two or 3 years of college, I was thinking, oh, maybe I'd go back for my master's after getting a job or something. And then I had a research experience during the summer after my 3rd year in college. And I loved it so much. I was actually working on an exoskeleton for children with cerebral palsy, and working on some data analysis and an experiment for that project. And I loved it so much. I realized I loved research a lot, and that's what I wanted to do. And so then I decided to apply to grad school for a PhD program. And I've really enjoyed it, but it's interesting how things pop up. It's not what I expected. It was all of a sudden I realized this is what I wanted to do. Being an engineer, though, was always something I was kind of interested in. My dad is an engineer, my grandfather is an engineer, and now my sister is also an engineer. So we have kind of this family legacy now of engineers, which is quite fun on that end.
Oh, that's totally superb. And now we have a question from Vinaya Anand. And Vinaya is wondering, in these skin suits, so when they're in this microgravity environment inside a space station or a capsule like that, how do you want your astronauts to exercise while they're wearing these skin suits? Are they going to be doing the same exercises that the astronauts are doing now in their normal clothes, or are there going to be new exercises too?
That's a really great question. And I think it depends on how we're using the suit, right? So if they bring it up to the International Space Station in the next couple of years, they'll be using it potentially with those exercise machines that are already up there, right? For Moon and Mars, we imagine it's probably going to look quite different because they might have modified exercise devices. Right now, NASA is looking at a couple of like smaller, more compact, low volume, low mass designs for new resistive exercises mostly. So things you can do squats or deadlifts or that sort of exercise. So those are the two kind of options we have. I think it's still a big question of how exactly would astronauts use the skin suit? How long would they need to use it for? Do they use it every day in their exercise protocol? Do they wear it during their daily activities? I think we have a lot of options because as a garment, it's a really versatile thing that we can kind of set up in different kind of operational scenarios.
Got it. And now we have a question from one of my favorite Nord Anglia students because her name is also Fatma. So Fatma Khan is wondering, when you showed us these pictures of these spacesuits, there were certain colors you were using. So there was like black and people wearing blue and sometimes white. So how did you learn about the dress code for space?
Yeah, it's really interesting. I will say the colors, I think, kind of happened naturally. It's like as we're looking for fabrics, it's we found this one. It happens to be blue. I think that's an okay color. I think that's maybe what they might have done. I know in the beginning, the first suit that they ever made, they found a fabric. It was a white fabric that they thought would work great. And they weren't paying attention to color. And they found it was a little see-through, which was not what they wanted, right? Nobody, even the astronauts, they don't want to wear something you can see through. So that ended up being a really important design consideration, which is why we switched to blue. And I think the black even kind of increases that a little more. So that's the consideration I've been aware of, but it's more, what we want to make this something that astronauts will want to wear, and how do we best do that? It's already this kind of tight compressive garment, so maybe some astronauts don't want to wear it. What can we do to make it comfier and more appealing? And the color is one of those things that we can think about.
Well, I would be all over a green one if you ever were thinking, that's just an idea for you.
It's funny that you said that, because when I started my PhD, I said, I want a green one. Green is my favorite color. So maybe I should make one, Fatima, and I'll let you know.
Please do. I'll come to the lab immediately if you do that. So now we have a question from a Nord Anglia student who's wondering, what are your views on, these spacesuits and, skin suit like clothes that are being made by companies that are sending people up to space right now, like I think Blue Origin, for example, in these. Do you get inspired by other designs that you're seeing people use currently?
Yeah, it's interesting. So especially I'm familiar with the SpaceX one, and it's really cool to see this world expanding beyond just NASA, right? And so, I think it's really inspiring to see other kind of in the commercial spaceflight industry, people really focusing on human spaceflight, because that has been really centered in NASA for a long time. So it's great to have this expand. And I also think it's really interesting on the spacesuit side, how things in reality translate to kind of like science fiction and movies, and how also it has the reverse effect, right? So sometimes it feels like the things we see in science fiction and movies kind of translate to SpaceX's new suit. Maybe that looks like something out of a sci-fi movie, right? Because I think we take from each other, which I think is really, really fun in that way. I'm a big sci-fi nerd, so that's something that's always really inspired me, and I find really fun about this field.
Definitely. I think they all look really cool. And I think about that a lot as well. I would be really cool if I could go into the lab wearing one of those sometime, So now we have a question from a Nord Anglia student who's wondering, and I think this is a bit of a thought experiment. So you talked about multiple countermeasures during your talk, like exercise, wearing these suits, having those simulated loads on your body. So having people feel Earth gravity, for example. And this Nord Anglia student's wondering, if you only got to choose one countermeasure, what would be the most effective one? Which countermeasure would you choose, Rachel, for our astronauts?
I mean, definitely exercise. It's the one we've been using the longest, and it's been proven. And I love the wearable countermeasures, and I love the skin suit, but I think we need more than just the skin suit, right? The skin suit is something we can use to really supplement and kind of augment these exercise countermeasures, but exercise is the really important one.
Got it. So that's putting that stress on our body even better, like it would happen on Earth. So that's why that exercise is so important. Do I have that right?
Yeah. I mean, excuse me. It's a way of loading the astronauts, both statically and dynamically. The dynamic loads are really important, where we're running or moving or having some sort of change in load on our body as we're working out. And also they think they're actually doing a really interesting experiment now, is how important is the treadmill? So especially for these missions to the moon and Mars, they might not have room for a treadmill, but there are some scientists who think that's a really, really important part of the exercise countermeasure protocol. So they're actually doing an experiment, I think, coming up, where they're going to test to see what happens if we don't do treadmill, or if we do use the treadmill. But exercise is really, really vital. And we know that from kind of spaceflight so far.
Got it. And now I have a follow-up question to that. And you showed us these really interesting spacesuits outside, and you showed us what you call the moon bloopers. I think I love that term so much. But
that was from my advisor. I'll give her credit for that.
Got it. Okay. Thank you to Rachel's advisor for that amazing term. How are people's flexibility impacted by being in space as well? So you mentioned the importance of exercise and having that stress on your body, but does your flexibility get affected as well? Because you mentioned your muscles start to break down a little bit also.
Yeah, that's a great question. And I'm not sure if I can give a complete answer for that one. I'd have to do some digging to make sure I'm giving you the right information there. But I think it's like anything. If you go up into space for 6 months and you don't exercise or stretch, yeah, you have an issue with flexibility, right? Like you're having an issue with your muscles deteriorating. So that's why the exercise is so important to keep us moving and active and healthy and flexible and strong when the astronauts are in space.
Got it. And now we have a question from Aditya. And Aditya is wondering, you showed us Earth and a picture of, we're on Earth right now. You showed us a picture of the moon and you showed us a picture of Mars at the end of your talk. Are there any other planets that you think about when you're designing these kinds of suits?
Yeah. I mean, I think short term, like maybe in my lifetime or so, Moon and Mars are definitely the big ones, right? We really want to get to Mars as our new destination. And the moon is our stepping stone to do that, right? We haven't been back to a planetary surface in 50 years. So we really want to go back to the moon as somewhere a little closer and test out all of these technologies before we go to Mars. I think there are definitely other planetary surfaces out there that are interesting, but they're probably a lot farther too. So, I mean, I was recently on a NASA challenge. So NASA releases these challenges for like college and graduate students. And so I was in a team where we were planning out a concept for a mission to Ceres, which is a dwarf planet, right? So that was really fun too. Really, really long mission, but people are thinking about these things, at least in theory nowadays. So there's an interest, but I think we won't see those for quite a while.
That is totally fair, but something to look forward to in the future for sure. And now we have a question from grade 4 student Darshil. And Darshil's wondering, what's on the inside of these skin suits? So if you were to turn it inside out, what does it look like?
Yeah, I mean, it doesn't look that exciting, to be honest. We're talking about the skin suit. You turn it over and you can see a bunch of seams on it. So I don't know if you guys remember from the pictures, there are these kind of ribbons running vertically down the suit. We call these stretch arrestor ribbons. They're making sure the suit doesn't stretch too much and kind of just making sure everything stays aligned. And so we have all the seams from those on the inside, but otherwise it's really just like a fabric garment, which is pretty crazy. If we're talking about the biosuit, the one that we use for kind of the spacewalks, or the concept of the one we would use for spacesuits, that one's going to look a little bit more complicated on the inside. So there's on any like EVA spacesuit, any of the spacesuits you use out in your spacewalks, there's an inner layer called the LCVG. It's the liquid cooling and ventilation garment. And so you might have seen pictures of astronauts with their like underlayer on, right? It's this like white garment and it's like got these like little tubes like funneled through it. And essentially it carries water through and it cools the astronaut down. So that's kind of a cool inner layer to spacesuits that you sometimes see pictures of, but most people don't know what it's for or anything. And I think it's pretty interesting and cool looking.
That is really cool. I think some days, even when it's really hot here in Cambridge, Massachusetts, I could definitely benefit from one of those.
Yes.
Now we have a question from a Nord Anglia student who's wondering, are the skin suits fireproof?
Fireproof, not currently. It's a great question. So like one of the things we're doing right now is we're designing these to use on Earth and we're testing them on Earth. When we send them up into space for long periods of time, they might have more requirements. I don't know if fireproof is one of our requirements, but one of the things that we keep thinking of is actually laundry. There is no laundry machine on the International Space Station, right? So we need to make sure these suits stay kind of clean and not smelling, even if somebody wears it multiple times. And there are things like microbial countermeasures, like a coating we can put on the fabric to keep it kind of clean and over long periods of time. And so those are things that we're actually considering also for long duration use of the skin suit. But yeah, there's a lot of requirements for sending things into space and what kind of materials you can send that will be looked into like later in the process of developing the materials for these suits.
So this actually brings me to another follow-up question from a Nord Anglia student. Do you have to potentially, so let's say this comes into fruition and people on the International Space Station wear these skin suits inside all the time. Are they going to have to wear a new skin suit every time they go up? How often, how many are they going to have to bring? How many skin suits should I pack in my duffel bag is what I'm asking.
Yeah, it's a great question. And I think it's still somewhat of an open question, right? It's how well can we get these microbial countermeasures to work, right? I imagine they're going to definitely need to bring more than one with them, right? Once one gets kind of used up, you dispose of it with the rest of the kind of garbage of the day, and then you have a new one to use. The nice thing is they're pretty small, right? So theoretically, they don't take up very much space. So if we bring a couple, it should be reasonable. I don't know the number yet, though. I think it's something we're still kind of thinking about. How would that actually work? And how many would we need? We also might need to prepare for the fact that these suits are really custom made for each person. But when you go up into space, the size of your body might change, right? So maybe we send up a couple different versions of the suit to account for that, or there's also ways we can account for changes in body size in the way we pattern the suit or the materials that we use, so that it's a little bit more robust to if your muscles shrink or get bigger or something.
And now you showed us this really cool picture of that parabolic flight. So that airplane that goes up in the air and then drops for a little bit, and you get to feel microgravity. So you get to feel what those astronauts on the International Space Station are feeling. And we're wondering, that's not an experience most of us on this call are going to have. Can you tell us what that felt like?
Yes. Oh my goodness. It was so crazy. Definitely the coolest thing I've ever done in my entire life. So I actually will start off with the way the flight works is we started off with 2 Martian parabolas, because it's not quite as intense, right? They kind of work us up. They do Martian, which is like 38% of our body weight. Then we do 1 lunar parabola, which is 17% of our body weight. And then they go into microgravity. So they work us up. And the first lunar parabola was the weirdest thing I've experienced in my entire life. We have videos of the whole thing. So myself in the picture, and then in the picture was also a colleague of mine and a close friend who flew with me. And there's a picture of both of us sitting there in lunar gravity, and our faces are just like crazy because we can't process what's happening. Your body is so used to being in 1G, it doesn't really know how to comprehend this fact that you're now way less, right? You're lighter, or you feel lighter. And I think the way we keep describing it is our brains broke, right? It just, we didn't know what to do. It was crazy. It was so cool. I jumped up. I'm pretty short. I am 5 feet tall, which is very short. And I pushed off of the floor in lunar gravity, and I hit the ceiling of the plane, which is something that I've never done in my entire life. So it was pretty crazy. And then microgravity was, yeah, I actually think that lunar gravity was a stranger experience and harder to process, or the lunar gravity was harder to process. Microgravity was also strange, though. It was actually very difficult to control your body, right? Before we get on the plane, they tell us when you move around in microgravity, you have to be very careful with how much you push off on things, right? Because if you push off just a little bit, you'll go flying in the other direction. And so it's like use very soft movements. And they tell you this and you know this, but then you get on the plane and it's your body just assumes that you can use the same amount of force that you can in Earth's gravity. And so it's something that really is tough to get used to. I would say I've only done 20 parabolas, so I'm still not an expert flyer. And I definitely was still floundering around a little bit, but it was really, really interesting to see how the body and the brain adapt to this environment, or how they don't adapt very quickly on these first 20 parabolas.
That is absolutely amazing. I'm going to have to think up some experiments. Hopefully I can get on one of those in my lifetime. That would be great. And hopefully you can come with me, Rachel. We can test things together.
That would be a lot of fun.
We'll be testing the green skin suits, actually. That's what we'll be testing. Yeah, absolutely.
That sounds like a plan. I'm in.
And now I'm wondering, we've North Anglia students who I think want to study this in the future. And they're wondering, what's the best thing to study in high school if you wanted to design spacesuits like you're doing now, Rachel, or if you want to be an astronaut and be the person wearing that skin suit in the future? What are some of the qualities these folks should start to develop and cultivate?
Yeah. Well, like I told you guys, when I was in high school, I did all of the arts things. I didn't do any of like the math or engineering club. So you guys might already be ahead of me on that since you're watching this presentation, right? I just did what I enjoyed. I loved arts and I loved theater and I loved being in band. And so I did all of those things that I loved. And I think I gained a lot of valuable skills there that have helped me throughout my career. So in theater, I learned to talk to people and to be comfortable public speaking and kind of gaining communications and soft skills, which is really important. And so, yeah, I think the biggest thing is to do what you enjoy, especially when you're in high school. And if you enjoy those math and science courses that are even more so preparing you for these future endeavors, I think that's fantastic. And definitely kind of do what you can, do what you enjoy. And yeah, and the same in college. Find something that you really enjoy, find a major that you really enjoy. Maybe that's engineering, but maybe it's something else. And do your best at it. And also, like, work with your professors and get to know your professors, because it's a really valuable resource that some people don't take full advantage of. So yeah, I guess that's what my advice would be. I think on the astronaut side, I've heard very similar things when I've talked to astronauts before. I think their recommendation is don't kind of aim to be an astronaut. It's hard to be an astronaut. You've got to have something that you really enjoy and you're really good at. To be an astronaut, you have to have something you're really good at, and that's what makes you qualified. So find something you're good at and that you enjoy, and that's the best way, I think, that I've heard to become an astronaut. Although, again, I'm not an astronaut, so I guess I wouldn't know entirely, but that's my advice.
It sounds like find the things that you love to do and do them as best as you can.
Yes,
exactly. I think that's a really lovely mission, and that's how you get to incorporate all of this design and art and engineering and science and math and what you do. It's all of these things that you really enjoy doing. So I think that's totally superb, and I encourage all the Nord Anglia students to take Rachel's advice to heart. That is definitely the right way to do things. So Rachel, unfortunately, we don't have time for more questions. This has been totally illuminating. And actually, we had a lot of questions about life elsewhere in the universe in the Q&A. And I wanted to hint that, if the students, the Nord Anglia students, are really interested in this, they should take a keen look and get excited for one of next year's challenges, because they might be dealing with that very question. So I wanted to pull that. And also, I wanted to remind students that we have one more MIT abstract this season. We're going to be talking with Makinde about physics and poetry. So just like Rachel, that art and science connection, that STEAM. So please join us for that. That's going to be a total delight. And now I just wanted to thank everyone from Nord Anglia, all the students, for joining us today and asking such superb questions. Thank you to the MIT Nord Anglia Education collaboration for making this series possible and for bringing amazing folks like Rachel to our screens wherever we are around the world. And lastly, I'd like to thank you, Rachel, for your illuminating words and for inspiring all of us to do the things we love as best we can.
Awesome. Thanks so much for having me.
Of course, it was a real pleasure. So now I'm going to let everyone go and we will see you next time. Have a good day, everyone.